Hello and welcome to BioRules video lessons. Today we are going to put together the knowledge that we just gained by studying carbohydrates and by studying lipids. So we're going to be talking about carbohydrates and lipids, and I start talking about the energy content in carbohydrates and lipids. So carbohydrates, they contain lots of energy. Lipids, they contain lots of energy. And just for you not to be alienated, I will put the proteins, which is the third kind of macromolecules that we're going to be studying after this, but I already talked about the energy content of those three. So carbohydrates, it has roughly 4 kilocalories per gram. So every gram of pure carbohydrate contains roughly 4 kilocalories. Okay, this is roughly 1 joule. Lipids contains roughly 9 kilocalories per gram, so it's twice as much. So gram by gram, 1 gram of lipids contains twice as much energy, roughly, than 1 gram of carbohydrates. So now you have much more energy per gram in lipids than you have on carbohydrates. What about proteins? Proteins are similar to carbohydrates. Gram by gram, it has roughly the same amount of energy as carbohydrates. So if you want to get energy, you can eat carbohydrates, you can eat proteins, you can eat lipids. The three of them are going to be giving you energy, but the one that give us much more energy is lipids. Just for you to have an idea, this is the table that I had before, adding the idea that triglycerides or any other kind of fat usually are found without any water, because they are hydrophobic, they don't like water, so you have absolutely no water there. But when you eat proteins and carbohydrates, usually there's water together. So this difference, that's almost twice as much energy in fat than in carbohydrates and protein, gets much, much higher if you consider that carbohydrates and proteins actually have water, that you don't extract energy from it in there. So fat, much more energetic. Okay? So gram by gram, lipids have twice as much or even more, if you consider the water, energy as carbohydrates and proteins. So if you're going for a hike, it's much more energy efficient for you to carry peanut butter than it is for you to carry something made of sugar or like a jam or something like that. So PBJ, peanut butter and jam, the peanut butter contains much more energy per gram than jam. And this is why we love fat. Our body likes fat. It craves for fat. Okay, we really, really, really enjoy food that is very fat. Sirloin, for example, tastes much better than muscle. Muscle is contains lots of proteins. Sirloin also contains lots of protein. The difference is the amount of fat. Sirloin contains much more fat than muscle. Our body stores fat because we evolved being able to eat some days but not eating other days. So we store fat for those days of low energy availability. So this is a fact. Our body stores fat. So what's the point? In the middle of the 20th century, actually, I don't remember if it was the Korean or the Vietnam War, the United States started doing an autopsy in soldiers that were dying, there in the war by war causes, not health problems, and they realized that many young soldiers that were totally healthy, they had plaques of fat into the blood vessels, into the arteries. This is called arteriosclerosis. So this raised an alarm because people dying from arteriosclerosis at older age was, people are getting old, there's a concept of getting old, but they realized that young people already had plaques into the heart. They are not dying, they are healthy, but they had the stuff that could become a big problem, could lead to a heart attack. So that was what made the start for the compulsion of the United States and then later of the world against fat. People start saying, okay, fat is bad because if you eat fat, we are going to start making plaques that will clot our hearts and are going to have a heart attack. So people start going diets. People start going light, fat-free, low-fat things. So this is where it started, because people start getting afraid of getting fat into the blood vessels, especially saturated fats, and later especially trans fats, trans or saturated fat, because they are the more solid ones. And because people start getting afraid of eating this stuff that could clot the blood vessels. Ooh, there's another however. However, number 2 is very well illustrated with this diagram here. This graph shows the percentage of the food that comes from fat. So this is fat calories as a percentage of the total calories. So if you are in the low side here like this, 10% of the diet in Japan comes from fat. From 30% of the calories are from fat. And then we go for other counts like this here, number 16, 22, whatever, 16. New Zealand, 40% of the calories in the diet come from fat. So basically what the x-axis here is showing us is that the higher the number, more fat in the diet. And what the y-axis is showing us here is the mortality of rate in those countries by arteriosclerosis and degenerative heart disease. So basically people dying from problems that are associated with blocking the blood vessels in the heart with fat. The point here is that there's not a straight correlation. There is a correlation. For example, but France here has a high fat intake. French like fat. They like croissants, they like foie gras and other stuff. However, they don't have many people dying from arteriosclerosis. On the other hand, with a similar intake, Finland has roughly the same amount of fat intake from into the diet, but they have much more. They have more than 4 or 5 times more people dying from arteriosclerosis than in France. And of course, you have the United States over there, the country that in this data had more people dying from arteriosclerosis, and they are one of the champions on amount of fat into the diet. But what we can see here is that very clearly there is no straight correlation. Yes, there is one thing here that's quite clear, that there is no people dying a lot in countries with low fat percentage. So countries that eat less than 20% of fat, you didn't have many mortality of arteriosclerosis. But the French people are there to show us that there is not a necessarily causation relationship. So eating fat not necessarily is making people to be dying. Otherwise, the French would be up there as well, because they eat a lot of fat. So what's going on? We can see here in this diagram that usually wealthy countries like North America, Europe, Australia, New Zealand, they have a high fat intake into their diet. So it is related to money. So what's going on here? What's going on actually is that fat, you may not eat it, but you may still produce it. So people broke the war against fat, against eating fat, but they forgot that fat storage equals how much energy we consumed minus how much energy we spent. So if you eat a lot of fat, but you spend a lot of energy, you're not going to be storing a lot of fat. If you eat a lot of energy and you don't consume, you don't spend a lot of energy, then you're going to end up storing. And we humans store fat as energy as fat. So basically what happens is that people eat a lot. They eat a lot and they don't necessarily exercise a lot. So what happened with the young men is that they were eating a lot, and yes, they used to eat fat. Fat has a lot of calories, but there's no point in being eating fat-free, but a lot, because you still eat a lot, and then you end up No, if you have too much energy, you end up having, you may end up producing fat yourself. It's like those people that say, oh no, I want a diet Coke because no, I want that cake fat-free because I am I only eat fat-free. Okay, how much of the cake you want? No, I want the entire cake. They eat fat-free, but they eat a lot. Supersize me, but fat-free, please. Okay. One example is this. What do you see here? Okay, if you're seeing eggs and fries, yes, that's what we want. That's what we like. We like eating fatty food because it contains lots of energy. But actually, this is yogurt, peach, and apples. Okay. Okay. So what should we do? One of the things that we have to pay attention to this class is not eat less fat. Is not even eat less. The message from this class is spend more. If you spend energy, then you can eat energy. You can eat all you want as soon as you spend it. I have a friend, he's a bodybuilder, he's no weight lift. Man, that guy he eats 5 times more than I eat. But he exercises a lot. No? So he's not overweight. He has lots of muscle. So you can eat all you want if you exercise. This is the bottom line here. If you want to know a relationship, there is one thing called BMI, Body Mass Index. The Body Mass Index is calculated dividing the mass in kilogram by the square of the height in meters. And here we have a table illustrating it. For example, we can calculate mine. I am 198. I will actually put over here, see, I am 198. And I am, on this day, 94 kilograms. 94 kilograms is something around here. So I would say I am something around here. And I am something around here. So I am, oh, look, I am pretty normal. 198 with 94 kilograms, I am quite normal. I'm with a BMI between 18.5 and 25. Actually, I'm probably on the limit to overweight. So, but this is how I calculate BMI. You may be asked to calculate BMI. You may be asked to find BMI in a table. Okay. Another way of finding BMI is using this table here. This graph actually is called a nomogram. In nomograms, we use these 3 axes to find what's the BMI, or we can find what's the weight of a person with certain BMI. For example, I'll get again here, myself, I am 198, so 198 is exactly over here. You see, I'm going to put a dot over there. And I want to know what's my BMI if I am 94. 94 is over here. So let's make a line between there it is. So if I do this, we'll look what I have here, 20, 21, 2, 3, 24. I'm almost 25. I am there in the 24 BMI, Body Mass Index. What you can do with this here is, as well, is to say, okay, I am, let me say here, let me get another color, which will be easy. I'll use red. Let's say that you are 160, okay? So you are 160 160 centimeters or 1.60 meters, and you want to know how heavy can you be but still be considered normal. Remember, normal is 25, right? So 20, 21, 2, 3, 4, and 5. 25 is over here. So how heavy can I be? 1, 2, 3, 4, and 5. If you want to be have a normal weight, so this is going to be it. So I'm going to be putting there. Here it is. Okay, so actually it got twisted in the end when I let it go. So here it is. There it is. So basically, if for you to be normal, if you are 1.6 meters, it will be 6123. 63 kilograms by this nomogram would put you in the limit of the normal weight. Now 64 already puts you above 25, so it would be in the overweight category. Okay, another example here, and this already have a diagram showing that a person that is 1.8123184 and it's on the limit of normal 25 BMI would be 985 kilograms. This is how we use this. You may be asked to use a nomogram, you may be asked to use a graph like this, and you may be asked to use the formula to calculate the body mass index in a near future. So get used to the three of them. Okay. Another issue related is anorexia. People sometimes get very afraid of weight. No, overeating and low exercise usually is a problem. But you may have an even, I want to say worse, but it's a more challenging problem, because some people, they get so crazy, so fixed with this idea of overweight that they go in the other direction and they go for bulimia and anorexia. Those are food eating disorders that are important for us to study, and usually are related for people becoming extremely underweight, or because they exercise a lot, or more common because they don't eat enough. And we are going to be discussing this in class. It's a very important debate. No, food eating disorders are very, very important issues in nowadays, especially among teenagers. Take a look on the exercise, give it a try, so you see if you got the idea, and especially to see if you are used to use the nomograms and the formulas to calculate body mass index. See you in the next one.